Welcome to the Dunelm Technology Podcast. Each episode, we're going to be looking at a different topic to do with technology, and this week, we're looking at the recent XZ Utils backdoor and open source security. I'm Matt Brading, one of the principal engineers here at Dunelm, and I'm joined this week by two guests, Rowan Powell, one of the tech leads from our teams, and Jan Claeyssens, the DevSecOps principal engineer. Welcome both.
Yeah.
Hi.
Rowan, you actually put a blog post out about this attack on the Dunelm Engineering Tech blog. Do you want to tell us a little bit about what it was?
So the XZ Utils is a package that was actually used for compressing a file format. So just a tiny little utils package. And because it gets bundled up essentially into almost all of the Unix and Linux distros, it was a key target for the attack. So they put an exploit in there, which we'll go into detail on. And that got lifted up to all the packages. And it meant that it gave them a route so that when you were doing SSH and it used this compromised package, then it actually allowed them to intercept the security and give themselves a backdoor into essentially anyone running that approach for SSH, which is quite the achievement, really. So it's a good thing they got caught.
Yeah. SSH for people that aren't familiar with that, that's a way for people to remotely log into servers, usually very securely, right? This is something that people trust. It's the industry standard.
I mean, it really is
Yeah.
the backbone of a lot of the internet.
Quite a scary thing to achieve. How did we actually find out about this?
It was actually weirdly enough discovered by an engineer who was testing some other things by doing this SSH login and suddenly noticed that it was running, I think it was about 500 milliseconds, so about half a second slower than it probably should have been. And that sort of just set off weird alarm bells. Went sniffing around and saw that it was trying to do a lot more processing and things than it really should have been. So from there, it was a case of the alarm flag goes up, people start digging around the code and find some rather suspicious looking commits where things like the safe print had just been replaced with a regular print and other small little changes that just slowly leveraged open a backdoor.
It's quite quite impressive. It was caught in such a unusual way, I guess. Just someone trying to figure out why why things were taking a little bit longer than they expected. Seems like a case of we definitely got lucky on this one that it was picked up.
A little bit of a lucky break, at least that's where it got caught. It may have got caught further down the line. But yeah, it snuck past all the code reviews, all the security sweeps and pipeline scans that were presumably going on.
Yeah. I think the world doesn't realize how lucky we were with this one because, like you said before, SSH is ubiquitous. It's being used everywhere. If they would have been able to compromise all those different Linux operating systems, yeah, it would have been log4shell all over again, or even worse.
Because it was giving them root access, yeah, which is basically you can do anything you can imagine.
Yeah, it was taking control of the SSH process that runs as system, and I think it even has kernel privileges. So, and as an added bonus, nothing of the SSH commands that would have been run after it had been compromised would be shown in the SSH logs because they made sure of that as well. So they were hiding their trace as well.
Yeah, it essentially would have just given them a master key to any server that uses that secure login, which you're never going to notice. You're not getting broken into anymore. The door's just unlocked.
And Linux, which though, I guess to end users, like consumers don't tend to use Linux, but it really is the backbone of the internet. So it was caught, I guess, relatively early. D Is it something that has actually affected companies and businesses, or was it caught before then?
the piece that set off the alarm bells was essentially the last piece that would have needed to go into place for it to be effective. So what they essentially got in place, what they merged in, was a set of functions that let them call essentially any function they wanted and evade the safety checks. So if the last piece that was proposed to be merged and released had gone in, then the door would actually have been unlocked. What they essentially did was get together all the keys and all the pieces of the keys that they would have needed. So as far as we can tell, the vulnerabilities that made up the exploit path did get out, but there shouldn't have really been any way to use them, and that should all be locked back down. So unless you've heard differently, Jan, I think people are mostly safe.
I did some digging, so there is a vulnerable package, but like you said, the missing piece for this exploit wasn't merged in. The only thing people can do is update, depending on your Linux distribution. I want to say distro, but like Linux distribution. glibc and the XZ package just updated to be on the safe side. But there is, at this point in time, no proof that a system has been exploited.
Do we have any idea who these attackers are that have done this?
So I believe we have, at the very least, their usernames, or the last I heard, it wasn't revealed if it was one person using Puppet accounts or whether it was multiple people working in tandem. We know of at least one key user that submitted a lot of the actual exploit code, but the way the exploit got in, because understandably you'd assume people are checking for security flaws, is a lot of other theoretically real and trusted users put pressure for certain things to get merged in. So whether those were real people or not, it's not super clear just yet.
Yeah, and it's one thing is sure, it took this person or multiple person a lot of time, months or even years, to gain the trust of the original maintainer of this particular package, then get granted extra permissions on the repository that houses the package. And that way they could stealthily add to their exploit over a long period of time.
Yeah, and from what I saw, it wasn't just one file they put in to the repository where there was bad things happening. It was lots of little bits and pieces spread out across that multiple repositories that allowed it to all come together.
Yeah, so Giatan, or Giat as the user was known, was actually contributing a lot of perfectly good code to quite a few different things. So it was really building up that social trust of, yeah, they're here to help out, they're fixing genuine problems, they're making contributions. But like you said, a couple of them were just a little bit suspicious across a couple of different places that all put this chain of attacks together. So it's something that was clearly very planned out. You wouldn't make those changes unless you knew the dominoes were going to fall in a certain way.
I think it might be interesting at this point just to sort of go back to the roots of how this was possible, and starting by XZ Utils itself was an open source package. I think people assume that all their software is coming from a trusted place, but what does it mean that the XZ Utils was open source?
Like you mentioned, Matt, most people don't know that a couple of core services that keep the internet up and running are maintained by a very small amount of people. As a good example, if I'm not mistaken, NTP, the Network Time Protocol, at a certain point in time, I think it was around 2017, 2018, was maintained by 6 people on a voluntary basis. NTP is crucial for a lot of other protocols. One of them in particular is the Kerberos protocol that allows you to authenticate on Windows machines. If your time is out of sync, you won't be able to get your tickets and you won't be able to log in. So there's a bunch of other protocols as well that rely on voluntary contribution of a small number of people. And I think we should highlight those more if we want to prevent attacks from like this from happening again. Like they found a perfect candidate with the XZ package, but something similar could happen with maybe NTP or a dependency around NTP, OIDC, which is another major protocol that is being used for authentication online. A simple one, DNS. Like everyone jokingly says, if you don't know what's wrong, it's probably DNS. But if that breaks, the internet will stop working as well. And there's a bunch of others. So maybe there are already companies or organizations like the OpenJS Foundation and the Linux Foundation that are providing a kind of safe harbor for packages to be maintained where they can provide financial contributions to the developers. I think this should be happening more and more.
When we're talking about open source and anyone can contribute, it sounds kind of scary, especially in this case when we're talking about an exploit. But honestly, so much of our technology is just built upon the work of people before us and built upon that to a scale I think really isn't obvious to most people. And it really, really accelerates what we can do with technology. Because otherwise every company would be starting from the very ground up and it just wouldn't be feasible. And obviously we don't want to make that all paid for. We don't want to lock it down because we'd lose all the benefit from that. But on the same hand, I really think, people and big companies should maybe start thinking about giving back. How can we contribute to open source? How can we help support the processes that are going on so it isn't just 6 people who are volunteering to try and keep this together and spot every potential attack. I'm sure you both know how difficult it is to review every line of code that we get in our own projects. You can only imagine how much work it takes to keep those things up and running.
Even like especially after you've done your day job, and then if you look with weary eyes, maybe around 9-10 o'clock in the evening, at a commit that someone else has made on your part-time projects, it could be easy to miss.
And I guess a lot of these things get started by the people not necessarily volunteering to run these big important packages. It starts with someone having an idea about something neat they could build and writing a nice bit of code and then deciding to share it out with the community. And then over time, that starts to become critical to these bigger systems that are running, multi-billion-dollar companies. And suddenly the amount of pressure that they have on them to keep their little side project running nicely and keeping it up to date and resolving any bugs gets higher and higher. I mean, that's exactly where this all started from, really, is as much technical detail as there is, as technically complex as this was. I guess, like with a lot of security things, really, it started with a more human attack, a social engineering almost of knowing there's one person, one maintainer for this package, and applying pressure to them to say, this. I think this is where these different accounts came into play. People sort of, these users, whether it's the one user or whether it was a team, applying pressure on the maintainer to get help for his package by saying he wasn't doing enough fast enough. And the main attacker that we see initially was there as a helping hand for him. And that's kind of, you know, something that anyone can understand, even if they don't understand the ins and outs. That it's sort of a, yeah, it's again playing on that at the end of the day, all this technical complexity that we have, it all comes down to various people around the world, and it's harder to, you know, protect yourself when you can get, you know, that kind of pressure put on you.
The old good cop, bad cop technique, and a little bit of peer pressure. It's like we're all human, and we're all susceptible to it to an extent. We just need to be able to spot them.
Because to your point, you know, with the, you know, you've got a group of 6 people looking after NTP. How do you know all 6 of them have the right intentions? That they're not, you know, that there's not one of them there who's just biding their time, waiting to, you know, complete a significant exploit like this that's complex, you know, over a long time. It's quite interesting. So what options do you think there are to try and, you know, protect against this kind of thing?
For this particular one, there's a couple of options that you have. It's like, it's 2024. Like, the need to have publicly exposed servers should be an absolute minimum at, like, in this day and age. There are a ton of options that you can leverage, like VPNs, be it like free ones, paid for ones, for companies, SASE providers, Secure Access Service Edge, because marketing and security like an acronym, which basically brokers a safe way to access internal servers. I think, Matt, you surfaced a couple of months ago that AWS has something like, I think it's called verified access, which is a type of secure access service edge service. What else? If you don't want to spend a lot of money, you could use, like, I'll stick to the AWS example because that's what I'm most comfortable with. IAM credentials and SSM. That way, you can use your IAM credentials to use the SSM agent that you install on the server. You don't need to expose the server publicly. You can just hop on using IAM credentials. It's all, everything that you do is logged. But also ask yourself the question, do we still need to log into servers? We should be using infrastructure as code as much as possible to declare everything that happens on servers. Logging should happen to a third party, and there's plenty of tools, be it infrastructure as code or declarative or immutable infrastructure, that you don't need to go on servers anymore. I think, yeah, the list goes on and on. Rowan, what's your take?
And I think more broadly, right, that covers how we do this one attack and keep our security standards high here. But more broadly, yeah, if we're using a lot of other people's code and a lot of other services, it's about keeping those to a minimum, keeping our security checks up to date, doing our due diligence, and to a certain extent, software at this point has become a bit of a black box, right? There is so much going on, you can't review all of it. But I think trying to do your due diligence, keeping your things like our SAST tools and our pipeline scanners on the alert, and really pushing for keeping everything as up to date as possible on trusted versions is really important.
Keep it simple and try and be lazy. Try and use secure defaults. Like, for instance, there are companies that are providing secure by default Docker images. Like ChainGuard is one of them. They provide Docker images that have been scanned and hardened, and they offer them free of charge to the community. Google has started something similar as well, where they are providing scanned and vetted by Google, I think it's Golang packages or even container images that have been scanned by Google. And to Rowan's point, keep your CI/CD security in check, up to date. And if you really want them to take the next step, you could look at governance and assurance frameworks like Google's Salsa framework, where you put various checks and balances in place in your supply chain, where you can actually attest in, like, I think 7 or 8 steps, what has been checked, what has been hardened in the CI/CD setup. And there's 4 levels of attestations. And this is a nice step to providing that extra level of security that you have done your due diligence.
A lot of the reasons why we have these complex supply chain is because it helps out developers at companies getting stuff done. Because to your point, Rowan, if you have to, start a website project, you don't want to have to write a HTML server from scratch. You don't want to have to write your own authentication frameworks. You don't want to have to write your own database. You just go out and people have done this work and contributed it for the community to use. So you use that and it gets you off the ground. And in some cases, that's definitely the right thing to do, because with some of those things, it's much better to go with an open source approach, not just because it saves you doing it, but like you say, with the battle tested things, people will have considered smarter people than you will have considered the best way of building this thing. And if it's a big package that's been there a while, it'll have gone through its own, life and had issues that have come up and been resolved, and these are all things that are hard to replicate if you build it from scratch. But I also know that sometimes it goes a bit too far, and sometimes people reach for that package manager a little bit sooner than maybe they should. And I think we've had some examples of that in the JavaScript world of these packages that provide nominally very simple functionality that people have picked up, and then it's spread, and because they're a dependency in another package, and then that becomes a dependency in another thing, and it's sort of it's hidden at the bottom, but suddenly it causes issues for everyone, that this one little package has suddenly become malicious.
A small package to do one function, and then you look at the dependency tree. Oh wait, this pulls in like 39 other dependencies.
Yeah. And I guess this is why we're saying, use your CI pipelines and automated scanners, because us as people don't have the time to sit and go through all the dependencies of every project, reviewing all the code, following each dependency down, all of that. The scanners can do that quite easily. They and pick up stuff that we might miss. And presumably, if this exploit had gotten further to the point it had been merged in and released, as long as it did get picked up that it at some point that it had happened, because the community shares these security vulnerabilities, all the scanners would have started picking it up, saying you've got this vulnerability here and here. So at least the businesses would have known what to start addressing.
The scanner that does this is the acronym is SCA, Software Composition Analysis, or SBOM scanners, Software Bill of Materials, which list all the dependencies that a particular package or library has. You can have, there's a ton of free dependency scanners for CI/CD, and there's also now more and more vulnerability management scanners that have an SBOM functionality as well, which is where this SSH vulnerability would have been picked up. It would scan the file system and then say, oh, hold on, you have this XZ package here that is vulnerable. And then you can patch your SSH, or what was it, XZ or glibc.
It's good as well to architect your application to be secure by default and not just relying on your packages to be secure. But if no one can SSH into your server because you don't have a server to SSH into, then you're definitely going to be safe. And yeah, there's lots of tools out there for doing that now. Obviously, Dunelm's a big user of serverless technologies, which means that you don't have servers to maintain in the first place, which takes a whole category of security risks away from you. But yeah, also, as you said, making sure you've got CDN or something in front of your services that's going to take that hit if you need to. I think one of the things I'd seen recently, I've not had a chance to use it yet, but there's Cloudflare Tunnel, which is it opens up a sort of trusted connection between their CDN and your origin server, so that your server doesn't have to be exposed to the internet. It just directly connects to Cloudflare. There's no way around it to get to you.
Like, developers want to develop fast, and businesses want to make money, and there's that risk appetite that every business needs to make and decide, okay, we are happy with this level of risk. I can imagine if you work for a financial institution, you'd want the least amount of dependencies as possible, and there, well, yeah, the job might require reinventing the wheel on a couple of libraries. If you work in a vertical where it's key to be first to market, then risk appetite might be slightly higher, and then you have to have processes in place to do the security remediation at pace. So yeah, every company needs to decide for its own what its risk appetite is and how to tackle these things.
There's no one right answer that everyone can pick up and use. There's good practices and good recommendations, but yeah, at the end of the day, it's down to each circumstance to decide what's right for them. And I think it's interesting, certainly in my experience. I guess this is very relevant for you, Jan, but DevSecOps seems to be becoming more and more a thing. I think where in the past there's been quite a big gap between engineers just pulling in whatever package they need, deploying out kind of in one area, and then security in another area, looking at much bigger picture things and making sure everyone's machines are secured, things like that, but not necessarily looking at what's being pushed out in the code. And is it worth just like an explanation of where DevSecOps fits in?
Previously, security was roped in at the last minute, which made it historically very expensive to fix bugs or security issues when everything was already deployed into production, especially when you had monolithic services that would cost you like 2, 3, 4 sprints a quarter to get the next release out. When DevSecOps came in, the aim was to shift the security controls and checks earlier into the software development lifecycle. So rather than just looking at when it was deployed, you could look earlier in your earlier development phases. Like if you have a pre-prod or UAT, QA, dev environments, you can put your checks and balances there, or you can implement scanners in the CI/CD pipeline, and that helps surface security issues earlier. But alongside that, what I think is really important, and this is why I have to say, Matt, thanks for inviting security onto this podcast. It is facilitating and keeping the comms open between DevSecOps and engineering. We shouldn't be seen as adversaries, but as collaborators.
There's a mindset to adopt and to have security in the sort of back of your mind at all times when you're doing things. And again, it comes into the point that you made about how quickly I think engineers particularly like to go, and sometimes that's required of them from the business, from any business. But it's thinking about it, are you making a compromise on the security what you're doing. It's easy to assume that something somewhere else will keep your thing secure, you know, and that you don't need to worry because, somewhere else there's something that will protect you or someone will pick something up. And that is often the case that we have, say like we talked about CDNs earlier. Often most companies will have their websites behind a CDN that starts to provide a layer of protection. You can have your WAFs, web application firewall, and that sits there, and that will protect you from attacks as well. But that isn't everything, and you have to make sure every level you're considering, the security of your application. Don't just think because you're, writing a back office thing that's, maybe it's only available if you're on the company network. So therefore you don't need to worry too much about login because, it's just you'd have to be on the network anyway. It's you have to assume the attackers at your front door.
I think you've mentioned before, it's like there will always be smarter people than you. No one has all the answers. We can't go to developers and say, "Oh, didn't you know about this security thing?" And at the same time, developers write the code. No one will understand their code better than developers. And like I think for that, Rowan, I think you're doing a great job. Like with your presentations on the most common application security attacks that you're given are a great way to educate people. Like education is a first step in making sure that security is embedded
into the mindset and away from it being pen testing is separate, security scans are separate, and instead getting into the mindset of this thing I'm building, how does it get broken?
I thought it was particularly interesting, Rowan. You've obviously contributed quite a lot to the Dunelm Tech blog, and I think only a few weeks before this happened, you'd put out a sort of theoretical article about a very similar attack happening, which may have seemed, I mean, it seemed very plausible the way you described it, but people might have thought, okay, well that's just a just a worst case scenario, it wouldn't happen, and then turns out that actually, yeah, it been going on, and I guess we have to assume that it's happening in many other places at the same time. That we, as you say, as we said early on, we got lucky with this one, but this isn't something that we can just sit back and go, okay, we caught this, we're safe. People like these attackers will be carrying out similar plans across many parts of open source software, and we have to get more used to being like mindful of that, and how we can support the people who are on the front lines of that in terms of the open source contributors, how we can provide a safe space for people who want to use the open source software, like say with companies providing like vetted packages that they've had their security experts review, and they say they're safe for the community to use, and then each of us in our context making sure we have the right tools running to check these packages that we're using, and make sure that we're kept safe from it. Well, that's it for the first episode of the Dunelm Tech Podcast. Thank you for listening, and thanks again to my guests, Jan Claeyssens and Rowan Powell. We'll be adding links to everything we talked about today in the show description. And if you enjoyed the show, make sure to like and subscribe. We'll be having new shows coming soon. And also make sure to check out the Dunelm Engineering blog. Thank you again for listening, and we'll see you soon.